Hello, everyone. Hey, so it's really challenging to speak immediately after lunch, as always, and also for you, but let's start. My name is Eliran Natan, and I'm a software architect at Axonius. Axonius is a cybersecurity software. And I'm very excited to be here in JNation for the first time. And today I'm going to focus on domain-driven frontends. But before we dive into what that exactly means, I want to share with you a common problem, a common issue that we always face when we develop front-end, right? So, well, whether you read about software architecture, whether it's online or in textbooks, you always find these great monumental patterns like domain-driven design, clean architecture, microservices, event sourcing maybe. But well, I've been building scalable systems for the last decade now, and whenever it comes to front end, we always encounter this simple, monolithic layer piece of software that is usually composed of components. Sometimes it's smart or dumb components, and sometimes we have some state management solution. So I was wondering about this gap that we always have between backend and front end. And well, there is some chance, and that's I think that's the one of the most important things that I want to pass in this talk, is to use or utilize backend architecture or ideas that that emerges from backend to frontend. So I think that this gap has something to do with the common assumption that domain logic, that business logic, is fundamentally more complex than presentation logic. So we don't have to have these complex patterns to handle this presentation logic. But in fact, it might have been true like 10 years ago, but in today's realities, UIs are no longer just forms and buttons, right? They are these complicated applications, game-like applications that aim to deliver this significant added value to users. And this added value, and you can think about it, the more added value that we want to deliver to users via the UI, the more complexity that we have to tackle. Yeah. So let me just give you an example from my world, cybersecurity world. Well, imagine that your platform supports some complex query language, and you want to allow users to retrieve complex data by writing some complex query. You have maybe 3 options to do that, right? You can allow users to directly write complex query in some input box, click the button, and retrieve the data back. But this is there is no added value to users here. You're not helping the users in creating this query, and thus you don't have any complex presentation logic to handle. You could also allow users to build dynamically some queries, like adding a pre-filled drop-down boxes, and like building this query like intuitively. And this is more complexity. This is more added value, more complexity. Of course, that you can take it to the extreme and build this graphic drop-down interface where you have canvas and users can drag and drop entities onto that canvas and make these different kind of connections. Or when they hover above the canvas with some entity, they can see where they can drop entities or not. Just think about it, how much complexity you add when you want to deliver this added value, and that complexity should be handled. And it's not part of your original business logic. It's not something that your backend can support, right? Because your backend doesn't care whether whether you're helping users in building these queries or not. So that leads to a new concept that I thought of. I call it presentation domain, which really means that when we introduce added value, we also introduce a new domain similar to the business domain that we are handling, but that's a new domain that emerges when we try to present the business domain. And that really encompasses all the different entities that suddenly emerges and the entire dynamics between them. So when we think about presentation domain, we starting to think in terms of, okay, let's tackle this complexity. It's not that simple anymore. So unfortunately, I think that the leading UI frameworks have trained us to think in terms of components rather in terms of presentation logic and presentation domain. Most UIs are this mixture of presentation logic and infrastructural concerns. And that presents 4 main issues that I've encountered quite a lot when it comes to frontend. And I've seen it quite everywhere. I was working in Manhattan, in Amsterdam, and in Tel Aviv. And when it comes to frontend, you always see the same stuff. So the first problem is testability. It's very tedious and difficult to test components, especially when they grow and are engaged in various logical concerns. The second problem is reusability. We often, when organizations grow, they want to support multiple platforms or move between frameworks. And usually they have to rewrite the entire app because presentation logic is heavily tangled with your infrastructure or your framework. And I think that some of you probably experienced this. Well, it's quite harsh to realize that you cannot reuse your application. And a deeper problem is the splitability issue. I don't think that there is such word, but I think you realize what I'm saying. It's like we often see this arbitrary or artificial division of responsibility between front-end teams. Sometimes it's about teams owning components or owning pages or views or models. But this is not how user stories are organized, right? And you usually see multiply teams have to coordinate a lot and cooperate in order to resolve a feature, right? And that creates a lot of bottlenecks, especially at scale. And the last problem, and that's probably the deeper one, is the expressibility, which means that front-end code is often composed of these synthetic or artificial made-up concepts that are invented by developers, but they don't have a real meaning from the UI perspective. Like it's very hard to understand the code, and it doesn't really naturally relates to to your presentation domain. So, well, you can really see these problems emerges when you build front-end at scale, at serious scale. Now, I think that the root cause of this problem can be summarized with this sentence. We keep mixing up the what and the how. What is the presentation logic, and the how is the infrastructure. It's our data sources. It's the framework that you are using. And sometimes I think that front-end developers sometimes avoid thinking about architecture or design patterns because they expect the UI framework to implicitly deliver this design. But UI frameworks essentially won't give you a design or an architecture. That's not what they do. So what we really want to achieve, at least conceptually, is to have this core layer that captures the what, right? And it's completely logical and pure. It really represents the natural entities and processes that happens within your presentation logic. And then you want to have this infra layer, which is completely isolated from the core layer. And that really contains your data sources and frameworks. Now, most frontends today are not built that way, right? You mostly find this logic spread across the various components. And of course, that in order to mitigate the two, in order to keep your core layer isolated, you would have to have this adapters layer, this layer that mitigates between them. So that's heavily inspired from the clean architecture or other layered-based architecture that you know. And that's something that I think that we can bring to frontend. That, at least from my experience, that is a more scalable way to build frontends. So let me just give you an example, a concrete example. We can think about the Mvvm pattern, which really matches this layered architecture idea. This is just one example for a pattern, but you can think about a lot of patterns that can work here. So MVVM is really simple. For each view, you have a view model, and the view model interacts with the actual model, right? So that really fits into the patagram that we were just talking about. So the view model acts like this adapter between the view and the model itself. Now, let me just give you a concrete example with React. So luckily, in the last few years, leading UI frameworks have realized the need to write logic and stateful logic outside of the context of components. So we don't have to do that anymore. We can extract pure logic outside of components and really achieve the architecture that I'm talking about. So this is an example of implementing the card, and I'm defining here a custom React hook. If you are a Vue fan, then of course composition API and composables is the equivalent stuff, right? You can do the same stuff. So I'm defining here a custom React hook, which is my view model. And that's a code that I really like. It's really enjoying seeing, because the UI component is completely clean and easy to test. It's pretty pure. You just get all the functionality that you need and use it directly. And your view model is implemented with lower hooks, lower level hooks like useState and useEffect. And it really interacts, it can interact directly with the model. The model should expose some well-defined API, like we call it the use cases. This is also inspired from the clean architecture. And basically, it's very easy to test as well, because it's a function, it's pure, and now we have a clean separation between functionality and UI. Yeah. So I think that it's cool that modern React really matches these ideas. Now, of course, that free UI framework is not the only thing that you want to separate from your code, right? You also have to handle the data sources, the stuff that brings that data into your app. And that's also something that we can separate. Like we have some data source that is part of your infrastructure. It can be your local storage or HTTP call, Redis or whatever. And a repository, which is your adapter. So we are applying the repository pattern, again taken from the backend world. And the repository can, in fact, communicate with the repository interface that is defined as part of the core app. And this is where TypeScript really shines. Because with TypeScript, you naturally can define interfaces, abstract interfaces, and the core can rely on that repository interface. It doesn't have to know about actual repositories that use it. It doesn't have to know about the actual data sources that you're using. This makes your core app extremely scalable, and usually you don't have to change your app when you plug a new data source. So this is also very important. In order to keep your core app really isolated, you have to use dependency injection or the invert of control, right? Because you don't want your model to directly import repositories, right? You need to inject these repositories into your core app. That really keeps your core app isolated. If you have questions about this part, I can answer it at the end of the presentation. So just to understand how it looks like, I'm using TypeScript because I think it's very natural to this process. So I'm defining a product repository interface, and that's very abstract. And my core app uses this repository. It doesn't care how it is implemented. And when you want to plug in your new data source, you just have to implement the actual repository, right? You implement it, and it is like a translation layer from your actual data source to the API that your core app expects. And luckily, again, React can really help us, or at least modern React can really help us with dependency ejection, which means injecting your actual data source into your core app without breaking the rule of dependencies that points inwards. So here I can just use a React context. Inside the React content, I can define my repository, and then I can wrap any component that requires this data source with the associated provider. Right? So I think that it's cool that React really have everything necessary in order to complete this cycle. From one side, you have custom hooks for interacting with view models, and from the other side, you have React context for dependency ejection of data sources. So yes, React context can be used for dependency ejection. I think that this is one of the major goals that React teams had in mind. So together with Mvvm pattern that I showed and the concept of repositories, you get something that we can call technology agnostic frontend, which is stronger than framework agnostic frontend, right? Because it's completely isolated from the actual technology that you're using. Cool. So, well, by applying these patterns, and from my experience, we could show that our testability and reusability are significantly higher, dramatically higher. Right? It's very easy to test pure functions. It's very easy to use your core app when you want to support other platforms. So we actually could use the core app to support a mobile app or two different mobile apps and two different applications. One was very small that was written in React, and the other was heavier and it was written in Angular. So we could produce as much as versions of applications that we wanted by reusing this core app that is pure JavaScript or TypeScript. Right? You're not bounded to the framework. So now I would like to talk about the problem of splitability, a major problem that we often have with frontend. And what I showed right now is not really helpful in solving that problem. Well, we often see this, as we said earlier, we often see this arbitrary division of responsibility between teams. And I'm sure that if you're a front-end developer, you probably was in some team that owns some components or some models. And it always feels not really natural, like you just arbitrarily choose stuff that your team supports or not. But actually, when it comes to resolving a user story, we always see teams having to coordinate and cooperate together, because this is how it works, right? Resolving a user story affects this portion of code that belongs to multiple teams. And what we really wanted to do is to have a nicer flow of concerns, right? And so we have to think about how user stories are actually organized. And user stories are actually organized around business concerns, not around components, not around how you decided to build your app, right? It doesn't care about the structure of your app. It cares about the essence of your presentation domain. So you can split your presentation domain in a logical way, like defining like a very classical e-commerce app can be composed of a catalog, an ordering flow, a delivery flow, or support flow. And then you find out that user stories always emerges from these subdomains of your presentation domain. And if you have teams that own subdomains, they do not own any specific part of the software, they own subdomains, then you might find that resolving a user story is the work of a single team, and a single team can resolve the story end to end with little to no cooperation with other teams. And that's really good, not because we want people not to speak with each other, but because it makes the developer experience much better, and it's much faster to develop. So well, I just want to point out this is there is a wider discussion here about Conway's law and why it really relates to that, right? How can you promise that when you divide your teams according to subdomains, then they necessarily produce the software that is still splitted as you want? And not that with time, this software will be tangled again. And that's what Conway's law promises us, right? Organizations tend to build structures that mirror their own structure. So we can have this assurance that we will still get the software that we want. Of course, that you can take it to the extreme level and physically split your code by applying the micro frontend architecture, which is also very strong. And then you get a more isolated and higher, like increased autonomy for each team. You can also apply the BFF pattern, the backend for frontend. So it gives another layer of autonomy for teams also on the API level. So my point here is that a solid ground for greater teams' autonomy starts with aligning with business aspects. So you start to think about domain rather than technology, and then you get teams that are much more autonomous. Yeah. And this is where strategic DDD comes into picture. Strategic DDD is about taking the time gathering your domain experts. And when we talk about presentation domain, it means taking the time and gather your product owners as well and your UX designers and come up with this, what we call bounded context, right? This ambiguous language that everyone understands and can reason about. This is about building a common language for developers, for any stakeholder, to maintain software in a much clearer way. So, well, we can say that the front end is a technical implementation of bounded context. Like each subdomain of your presentation domain can be split into different subdomains, and each subdomain can be represented with a bounded context. So these are all terms that are taken from domain-driven design, and I think that it's time that we adopt them and utilize them in front-end development. Now that autonomy can be resolved with strategic DDD. And well, the last part that I want to talk about is the expressibility part, the problem of writing code that speaks the language of your presentation domain, right? If we have a cart, or if we have some specific flow in our UI, we really want to be able to read it from the code, to understand it from the code. So this is where we can continue with our domain-driven design thinking. We have this bounded context that is really defines this language, right? And we can think about different terminologies that people can speak about, right? But there is more into it. There is something that we call tactical DDD, which is actually fine-tuning your implementation. So with tactical DDD, it's not just that you build this language that everyone understands. You can actually model it by utilizing some great domain-driven design patterns. So you can split your terminology, and that's again about taking the time. There is no algorithm for that, right? You have to take the time and gather your domain expert and really brainstorm about it. And I've found from my experience that it's worth the time and investment because this is crucial for the success of your implementation. It can also drastically simplify your implementation because when you build software that matches some bounded context, you don't have to build it for other bounded context, right? Each team has its own language. They don't have to interact. And then you have simplified concepts that are really easy to reason about. So here I'm just showing this sketch where you divide your entities, your terminology, into aggregates, into aggregate roots, into entities and value objects. So entities are defined by their continuity and identity, while value objects are defined by their as properties of other entities. And well, that's a bit too deep for that. And so I think that together, now you don't have to adopt all what we talked about right now, of course. You can take part of this talk or get some inspiration about, well, you have the general inspiration of adopting backend architectures or patterns to your frontend. And you can also be more specific by applying building technology agnostic frontend, and by utilizing domain-driven design to make your code readable and much more maintainable. So just this very small summary of what we were talking about. We say that modern UI are complex, and we have to treat our presentation logic as a whole new domain and tackle that complexity in a serious way. So technology agnostic frontends can enhance testability and reusability, and we showed an example using the Mvvm and repositories. We also saw that modern UI frameworks, together with TypeScript, are very suited to implement such ideas. And this is from my experience that really works, and that's great. And we also showed the deeper level when you come to implement your actual core app, and you can think about building teams that around business aspects rather than around technical concerns, and that will enhance the team's autonomy, and autonomy is important for everyone. And finally, you can fine-tune your implementation, apply tactical DDD to make your code more maintainable and aligned with the domain model. Yeah. So that's it. Thank you very much, and I would love to hear some questions. Any questions? Oh, yeah, that was clear. Thank you.